Hi everyone and welcome to another MMS tutorial. My name's Will and today's tutorial will be all about the newly implemented mission analysis features. First, I'll show you all the available analysis tools that you can choose from. Then we'll have a look at how to generate a report, and to finish off we'll have a little look at the output when a report is generated. So here I've set up a fairly trivial scenario in MMS. You can find previous tutorials on how to set up a mission scenario on our YouTube channel. We can see that this scenario involves orbits with multiple eccentricities, inclinations, and semi-major axes, as well as multiple ground stations positioned around the Earth. This will be useful to highlight and visualize the capabilities of the mission analysis feature. So if I navigate to the analysis window, we can see 4 sections. The first section I'll focus on is the top left, which is the mission breakdown section. This provides a detailed summary of propulsion, impulsive burns, mass variations, and contact points throughout the mission. This can help assess the effects of thrusts, mass changes, and maneuver execution on spacecraft behavior. For example, we can see for each ground station we have a list of the contact windows between it and the spacecraft. This includes the start and end point of the window and its total duration. The next section we'll go through in the top right is position versus time. This provides a figure that visualizes the X, Y, Z and resultant positions of the spacecraft as a function of time. We can choose to select or deselect certain components. For example, if I just wanted to see the resultant position, I can deselect X, Y and Z components, or whatever you'd like to view here. You can choose any combination. Next up, in the bottom left, we can see velocity versus time. This works in a similar way to position versus time, but we can see that we can now select and deselect the X, Y, and Z and resultant velocity components. Finally, in the bottom right section, we have the Keplerian elements versus time. Here we can select one or more Keplerian orbital elements to plot against time. So we can choose semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of periapsis, and true anomaly, or any combination of these. Now I'll show you how to generate a mission analysis report. To start with, make sure you selected the correct spacecraft to generate a report for. Here, I only have one spacecraft, so it doesn't matter. So we'll start with the mission breakdown section in the top left. To add this section to our report, we simply select the Capture Data button up here, and we'll see it pop up in the Mission Analysis Report tab over here. We can then select these boxes to add a title and a description, and I'll simply add a quick title here, and a simple description. I'll then move on to the top right section, position versus time, and select this view and capture button in the top corner. This will enlarge the figure and allow us to see exact values at any given point. For the purpose of this tutorial, let's say I only want to include the resultant position versus time. So I'll deselect X, Y, and Z components and only select the resultant position component. I can then select the Capture button to add it to the report. If I now scroll down in the Report tab, I can see the figure added. I can add a title, and then select the Show All button to return to the previous screen. Next up, we can hit the same View and Capture button for the velocity components, and we get the same detailed figure as we did with position. Now let's say for the velocity we want to include in the report everything except the resultant velocity. So I'll keep the X, Y, and Z components and deselect the resultant velocity component, and then I'll click Capture to add that to the report. I'll add a quick title again to provide clarity in the report, and then return again to the previous screen. Now finally, we'll click the same View and Capture button for the final section, and we'll see once again an enlarged, more detailed figure. For this section, I'm going to add a figure including the inclination, right ascension of ascending nodes, argument of periapsis, and true anomaly of the orbit. So I'll click Capture, and I can then scroll down to the bottom of the Report tab and add another title. Finally, let's say that's all I wanted to add to my mission analysis report. To actually generate the report, I'll scroll back to the top of this tab and hit Export Report. Here we can see the report that was generated. So firstly, we can see the mission breakdown section and the title that we added and the description that we added. So we can see the spacecraft analysis and the contact analysis. We've also got the second section that we added, the resultant position versus time, in a nicely formatted figure, and the velocity components versus time, and finally the orbital elements versus time. That wraps up this tutorial for today, but if you'd like to see a bit more about MMS, please check out our socials for any upcoming videos, and also our YouTube channel for any existing tutorials and feature videos. You can sign up using the link below to receive a 14-day free trial, and if you'd like to learn more about MMS, please drop us an email and we'd be happy to jump on a call with you and chat about any requirements you may have. Thank you for watching, and see you in the next video.